Okay, question 1 says that a minus 5b and a minus b are perpendicular, and then it says the magnitude of a is 1, and we have to prove what a dot b is. So if these two vectors are perpendicular, that means the dot product of those two equals 0, right? So this is kind of like that question we did in the example. We can just expand that out, so it's going to be just like FOIL, going to be a dot a minus a dot b minus 5a dot b. Like, I'm not going to go over the foiling too much. You guys know that. And then plus 5b dot b. Now we have to remember one of the properties we have. A dot a is the same thing as the magnitude of a squared. So it becomes that. Group those like terms just like this. And then again, b dot b is going to be the magnitude of b squared, like that. Now we know a and b are 1, it said. Oh yeah, not just a and b are 1. So that becomes just 1 itself, minus 6a dot b. And then, plus 5 times 1 is just 5. Again, all of that equals 0, so let's move that to the other side. So we're just going to leave our negative 6a dot b on one side, the 1 and the 5 go on the other. And then, of course, we have to isolate for a dot b, which is negative 6 over negative 6. It's 1. Okay. Question 12. It is that proving that a dot b, a plus b dotted by a plus b equals that whole other side, which is kind of obvious. It's what we did in the last question. Again, FOIL. You get a dot a plus a dot b plus a dot b plus b dot b. And again, we're applying that same rule. Magnitude of a squared plus 2a dot b plus the magnitude of b squared. And that's your answer right there. Okay, 13. Okay, it said that a equals b plus c. And we're just trying to prove that the magnitude of a squared is going to be that other side that it showed. You guys will have it. Well, I guess I read it. It says b squared plus 2b dot c plus c squared. So again, we're going to start off with this formula. The magnitude of a squared, we know it equals a dot a. That rule again. Well, a we know is b plus c. So what we really have is the magnitude of a squared equals b plus c dot b plus c. And then again, when you expand that out, you already know from our last two steps, it just becomes that again. Magnitude of b squared plus 2b dot c plus magnitude of c squared. And it's not because these are unit vectors, it just always is. Like, one of the properties is u dotted by u is always the magnitude of u squared. So we have b dot b here, becomes b squared regardless if it's 1 or not. Okay, question 14. Okay, we have 3 unit vectors. Or no, sorry, they're not unit vectors. We have 3 vectors that are 1, 2, and 3, I think. Yeah. And we're trying to find out this u plus v plus w dot u plus v plus w. Again, you'll notice we have something dotted by itself. That's basically the magnitude of u plus v plus w squared. And we have the magnitudes right in the question, so let's go and find that. It's going to be 1 squared plus 2 squared plus 3 squared. That's going to be 1 plus 4 plus 9 is going to be 14. Don't forget all of this is squared. The square root of 14 squared, they cancel out, it's just 14. Okay, 15. What even is 15? I wrote it down. Okay, it's u dot v. No, u plus v dot u plus v plus u minus v dot u minus v. And if we remember everything we did before, you guys could probably get it right now. It's going to be, I'm trying to do this as fast as possible, by the way, so you guys are going to go to sleep before I can do it, so sorry if I'm going too fast. Whatever, it becomes u dot u again. We already know that's the magnitude of u squared. When the two go together, it's going to be plus 2 u dot v, and then v again, magnitude of v squared. We did this multiple times. Plus, now these are subtracted, so it's going to be magnitude of u squared. Now it's going to be minus 2 u dot v, and then plus our v squared again. Pretty self-explanatory. Cancel these like terms, right? We are left with 2u magnitude of u squared plus 2 magnitude of v squared. Okay, this is where things start getting hard, so I'm going to slow down for this one. All right, question 16. Actually, I might just make this a new video. I'm going to end this video.